In this video, I will show you how to find the definite integral using the substitution technique. So let's get started. So we notice that we have some non-trivial expression inside of the radical, and we're going to replace that with a new variable. So let t be x cubed plus 1, then immediately we differentiate that as a function, and we find that dx is 1 over 3x squared dt. Since this is a definite integral, I'm also going to change the limits of integration. So when x is equal to 0, t is 1. When x is equal to 2, t is 2 cubed plus 1, 9. So plugging everything in, I have an integral from 1 to 9. And here we have 6x to the power of 5 times square root of x cubed plus 1, which is now t with respect to x, but the x is now 1 over 3x squared dt. So we can reduce x squared with x to the 5th, and there's still x cubed left. So writing this out, we have the following integrand, and here we have x, but we're only supposed to have t in order to be able to integrate it with respect to t. So it seems like the substitution wasn't successful. However, x cubed using this same expression can be redefined as t minus 1. So that means whenever I see x cubed, I can just write t minus 1. So we can use that fact, and after we factor out 2, we can replace x cubed with t minus 1. And now we have a very simple integral with respect to t. We can distribute t, write it in exponential form, and we can easily find antiderivative of this and use the fundamental theorem of calculus. So it's going to be t to the power of 5 halves over 5 halves minus t to the power of 3 halves over 3 halves, and all that we evaluate between 1 and 9. So of course we can simplify and compute this expression, but it's not the point of this exercise. So we found the integral.